Okay, in this video we're going to go over one of the 3D pictorial styles for drafting, and this is one that is kind of most commonly used, particularly in the field of engineering, and that is the isometric. So we're going to look at, in this module, we'll look at isometrics, we'll look at obliques and perspectives, and we'll do obliques and perspectives in the next lesson of the module. So one thing to just kind of note about isometric drawings is that they technically belong in what's called the axonometric family. So there are three different styles of axonometrics. There's trimetrics and dimetrics. What it's referring to is these angles here on the horizontal, and honestly the angles also between all three of them. So with a isometric, all angles, and that also all faces, are given equal emphasis in the drawing. So with an isometric, we can, if we focus on like this corner here on this block, in an isometric, all three of these faces around this corner are given equal emphasis. So this angle would be 120, this angle is 120, and this angle is 120. So all three faces and all three axes are given equal emphasis. Versus with a dimetric, you have two angles that are equal, so two faces are given equal emphasis, and then a third face is given less emphasis. And with a trimetric, all three of your angles are different. So with isometric, all three are the same. With dimetric, two of them are the same. And with trimetric, none of them are the same. Now, we're not going to do any practices with dimetric or trimetric. I just kind of wanted to mention them to make sure you know that they exist. We are going to focus on the isometric, which gives that equal emphasis. The reason why this is kind of preferred for engineering style drawings is because this way we can see the front, top, and side in all in one drawing. So when we were making our orthographic practices, we were actually looking at isometrics of those blocks and then breaking them down into orthographics. And what we're going to do in the practices for this this lesson is we're going to look at orthographics and we're going to break them down into isometrics, or bring them up into isometrics. So an isometric is a way to show 3D objects. It uses a 30-degree angle to show all three sides simultaneously. So the easiest way to describe it is that off of the horizontal, you're going at 30 degrees, which is why we're going to use that 30-60 triangle in these practices. The way some people do describe it is how I mentioned it previously, of having that 120 degrees between all three axes. But I feel the best way to understand it is to understand that that angle there is 30. So some tips for drawing isometrics is you always want to make sure that you are using your 30-60 triangle and that you're keeping it flat against your T-square while you have your T-square flat against your board. I know you've heard me say it. I didn't keep count, but I'm sure it was probably around 50 times in the orthographic practices I mentioned to make sure that your T-square was flat against your board. The same concept still applies for when we're doing isometrics. Use your guidelines. So creating very light guidelines is great for isometrics. Another thing you're going to see me do a lot in the demos is something called the subtractive method, where I kind of just build up an overall bounding box and then cut the part out of the model itself. So I like to think of it almost as if I had kind of a block of marble and I was chiseling away at it to make the isometric. Drawing very lightly with your pencil and then tracing over those guidelines. So that's very helpful, and it makes it very easy to erase those guidelines in the areas that we are going to subtract out of those bounding boxes. And then you can also use shading to help show the differences in sides. Now, this is not something I do in any of the demo videos you're going to see, but if we think back to those pictures we were looking at of isometrics when we were creating our orthos, they had shading on different sides to kind of help show different faces and different edges. So here's kind of a little bit of what I was speaking on when we were coming to that bounding box method of taking an overall shape and then kind of cutting different parts or pieces out of it. So we're kind of recognizing where different levels are, creating an overall bounding box, and then chiseling away the different parts or pieces, but always just starting off with a general box for it. We're using 30-degree angles. So if there was a horizontal line right here, we're projecting at 30 degrees, and all of those lines are still remaining parallel to each other. So this line is at 30 degrees, this line is at 30 degrees, 30, 30, 30, 30, and the same thing in the opposite direction. And all of our vertical lines remain parallel to each other as well. We no longer have the concept of perpendicular lines in an isometric drawing. So with the isometric, instead of having those perpendicular lines, line meeting at 90 degrees, we've got, that's one of the major differences here. And again, of just kind of taking an overall bounding box and cutting parts and pieces out. And these two shapes here do a good job of kind of describing how a lot of inclines are worked at and projected. Because when I have lines that would just be straight horizontal in the orthographic, it's easy to understand how they get drawn in isometric because we just project them at 30 degrees. But if I have a line that isn't parallel to that plane of projection, or a line that just isn't a perpendicular line or a parallel line, I can't necessarily just use a 30-degree angle because the line itself isn't sitting on a regular angle. So what I can do then is similar to with the orthographic projection, where I can find where the line starts, which would be right here. I could find where it stops and then locate the endpoints and connect the dots. The same thing here. If I know it starts here and ends here, I can then find that on the box where it would be lying on the planes of projection and then locate endpoints and connect. And that's again where that subtractive method can really come in handy to make things a lot easier for us of creating those sloped surfaces. Now for an isometric, again, we're using that 30-60 triangle. We're just going to start with our 3 axes. So this would be our front face or our x-axis. This would be part of our side face or our y. And then this would be to help construct our height or our z-axis. So you can think of this as our width, our depth, and our height. And I always just kind of start with just that origin point and draw my 3 axes, and then I'll establish what I want the width to be, what I want the depth to be, what I want the height to be, and construct a just kind of overall bounding box. So once I establish what I want that width and depth to be, I'll then establish height, and I'll bring my lines over for my height to connect. And where they cross and meet, I'll bring them then, I'll kind of flip the direction, still keeping my lines parallel, but bring them over to meet. So isometrics are commonly used to, you might have seen them in a lot of video games. I know a lot of the blocks in your inventory in Minecraft show up as isometrics. So maybe you're a little bit familiar with them from that, but they're just used a lot in a lot of video games because it can help show that object with a fair amount of detail in one singular drawing. So for the assignment associated with isometrics, let me just get over here. You have 6 drawing files. They're set up very similar to the way that your drawing files were for your orthographics, in which in the first column there is a picture of the objects that you'll be creating, and it is, instead of as an isometric, this time is as an orthographic. So it's showing us the front, the top, and the side view, and it is giving us some dimensions for what exactly each one of those is to help construct the shape itself. There is also a 3D model link in there, so if for any of these, if you wanted to click on it and be able to view the object 3-dimensionally, we'll let it load. A nice thing is when it comes in initially, it's in isometric mode already, so it kind of shows you what that isometric would look like. But then you can kind of orbit it around. If you wanted to use the measure tool to take measurements from like one point to another point, you can. And you can also, up here on this little piece, it's called the view cube. If you just click on that little corner, it'll kind of orient it back to an isometric for you. And then there's also a link for each one of these. There is a YouTube video that will walk you through how exactly to do each one of these. One thing to note before I let you guys get to work is that with this very last block, you're going to be doing it at half scale. So this is kind of the first practice where we're going to be doing it not full size. So that's going to be every inch on paper would be 2 inches in reality. So every measurement you see here on this drawing, you're going to half it. So instead of drawing it with a depth of 1.5, you'll draw with a depth of 3/4. And again, what I encourage you to do is try some of these out on your own, and then you can click on the drawing link and maybe skip to the end of it and see if your drawing matches mine, or watch the drawing through first and then try it out on your own. Don't necessarily just go through the videos and just watch me draw a line, pause, draw the line, unpause, watch me draw it, pause, draw it. Make sure that you're at least kind of understanding some of the concepts related to the isometrics. And if you're not understanding them, there are some resources. There's a textbooks chapter here. There's some additional videos related to drawing isometrics. And of course, you can reach out for help via email if you need any, or if you just want me to kind of describe it in a little bit more detail. And yeah, please make sure you reach out if you need any help, and I will speak to you guys soon.